Hi everyone, welcome back. Today we're doing product of array accept self in C++. For this question, we're given an integer array nums. So something like this. And we have to return an array answer such that every item in answer is equal to the product of all the elements in nums except the one in the same position. So for this first test case, this means the answer for position 0 will be 2 multiplied by 3 multiplied by 4. So this gives us 2 times 3, 6, 6 times 4, 24. For the second position, this will be 1 multiplied by 3, giving us 3 multiplied by 4, giving us 12. And for index 2 over here, this would be 1 multiplied by 2 multiplied by 4, giving us 8. And finally, this would be, as you smart parrots would guess, 1 multiplied by 2 multiplied by 3, giving us 6. So this corresponds with our output over here. So the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. So good for us, I guess. This means we can use the integer to manage the products over here. And we need to write an algorithm that runs in O(n) time and without using the division operation. For the constraints, we have 2 to 10 to the power of 5 numbers inside nums over here. And every single number would be negative 30 to 30. And in this case, as a follow-up, they are prompting us that it is possible to solve this problem in O(1) extra space complexity. And the output array does not count as extra space for space complexity analysis. So off the top of my head, a naive way would be to come up with 2 arrays. The first array, I will call it the left to right product. And this would represent the products where we take every single, where a position at this index would be 2 multiplied by the cumulative product of all numbers on the left. So this represents numbers from index 0 to index I for I in left to right product. So what this means is, like, at this position for this index 0 over here, this would be 1 over here because it represents all numbers until index 0. For the second one, in this case, this would be 2 over here multiplied by 1. This gives us 2 over here. For index 2, in this case, this would be 3 multiplied by the number on the left. So this gives us 6. And finally, the final index, in this case, this would be 4 multiplied by the cumulative product on the left. So this would be 24. We can also have a similar right to left product. So right to left product vector. And as you might guess, this represents the represents numbers from length from nums.size -1 to index I for I in right to left product. So in this case, this would be 4. This would be 3 times 4, giving us 12. This would be 2 multiplied by 12, giving us 24. And finally, this will be 1 multiplied by 24, giving us 24. And using these 2 arrays over here, we can take the answer at a given position. Let's call this answer. We will initialize this to be just the same size as nums, but with all numbers set to 1 first. So once we're done, we can take this position here for answer to be right to left product 24 over here multiplied by all cumulative numbers to the left of index 0. But in this case, since index 0 is the first number, so this would just be set to 24 over here. So just this one over here. For index 1, what this means is we can use left to right product at index 0 to represent all numbers from 0 to 0, so 1, and we can use index 2 in right to left product to represent all the product of numbers to the right of index 1. So in this case, this would be 1 multiplied by 12, giving us 12. And as you might guess, if we do the same thing for index 2, this would be 2 multiplied by 4, giving us 8. And finally for this would be 6. So just this one over here. And this would give us the answer as well. So this is nice and all, but it doesn't use O1 extra space because we use ON space in left to right product and another ON space in right to left product, excluding the answer array over here. So then we smart parrots will probably ask, oh wow, okay, so how do we do this then? Like yeah, so like another way I was thinking is instead of using this left to right product, why not just use a left and a right? Let's call this left product and right product. And we also have a current index as well. So the current index represents the current index that we're looking at. And the left product represents all numbers, represents product of all numbers to the left of current index. And we can initialize that as 1. In this case, similarly, for the right product, this represents the product of all numbers to the right of current index. So if current index is 0, then this will be all the numbers from index 1 onwards. So okay, I should just remove this. So in this case, this will be 2 multiplied by 3 multiplied by 4, giving us 24. So this is nice, and this makes sense because when we are calculating the answer, what we really need is just the left and the right product of the two adjacent numbers. So we can maybe pre-calculate them. And for the right product in this case, we can calculate it by iterating from the back to the front to get the right product. This is fancy and all, but let's quickly do a quick trace. Let's set answer to be 1s as well. And in this case, let's say we are trying to calculate the answer for index 0. In this case, this will be 1 multiplied by 24. This represents the product of all numbers to the left, but there's no number, so I'll just initialize this to 1. Just take it like as if 1 multiplied by itself would be 1 anyway. And for the right product in this case is the products from index 1 onwards. So this is perfect. Like we can just take the product of these two numbers to get the product of array as itself at index 0. So this gives us 24. And the next intuition is, okay, I will take the left product and multiply it by the number on the left now because we are moving this onwards. So this would be 1 multiplied by 1, giving us 1. And the right product, we would guess that we could just take this 24 and divide it by 2 over here, by the current number. So this gives us 12. This is fancy, but unfortunately we can't use division operators here. So this personally confused the crap out of me. I was like, wow, I can't do this. Then how do you expect us to use constant space then? Like, what's a better way around this? But it turns out after much brain damage, I realized that wow, actually we could just use the answer array as our right array, similar to the answer that we were thinking of before. So what this means is we could initialize our answer array to be our right product array. So this would be 4, this would be 12, and this would be 24, and this would be 24. And the idea is, instead of using this right product over here, which we can't use and update since we cannot use the division operator, we would just take the left product and multiply it by the number to the right, which represents the right product. So yeah, so this will give us 1 multiplied by 24, giving us 24. If we move on to current index 1, then this would be, we will update left product first. So 1 multiplied by 1 gives us 1. So we'll take 1 multiplied by 12, giving us 12. And for this index 2 over here, let's update this. We'll take the left product and update it with the previous number. So this is 2. And this would be 2 multiplied by 4, giving us 8. And if we move on to the final one, we update left product with 3. This gives us 6. And in this case, since this is the final number, this would be 6 itself. So this gives us the answer like this. So this gives us the right answer. And for our smart parrots who are rightfully skeptical, your next question might be, okay, but does this approach work for example 2? So let's quickly de-risk the worst case scenario of building this thing, only to realize that it doesn't work. So let's try it out with this test case as well. So first, we will define the left product. As usual, this represents the product of all numbers to the left of current index. And current index starts from 0. And the left product in this case would be 1, since no numbers are on the left of current index at the moment. And we will initialize our answer to be the right product from right to left as well. So we will initialize this to actually, one thing that I kind of noticed is we can just use the copy constructor to just assign answer to nums first. And what we do is we iterate from the second last index onwards. So we will take this number, this current number, multiplied by the accumulative product on the left. So this gives us -9. This 0 multiplied by -9 gives us 0. In this case, 1 multiplied by 0 gives us 0. And finally, -1 multiplied by 0 gives us 0 as well. So we can start off with this right product over here. So with that, let's start updating our answer. So for this will be 1 multiplied by 0, giving us 0. And we'll move on to the next position. So just before we start, we will take left product and multiply by the previous number, which is -1. So 1 multiplied by -1 gives us -1. Now we will take -1 and multiply it by 0 over here. So I guess I should just put a cursor over here to make it clearer where we are. So this would be -1 multiplied by 0, giving us 0. And we move on to the next position. In this case, we'll take -1 and multiply it by let's see, -1 multiplied by 1. So -1 multiplied by 1 equals to -1. And over here, we will take -1 multiplied by -9, giving us 9. We move on to index 3 over here. And we'll take -1 and multiply it by the previous number 0. So -1 multiplied by 0 equals to 0. And we'll take 0 multiplied by 3. So this gives us 0. And as you might guess, once we hit the final one, in this case, we'll take the left product and multiply it by -3, giving us still 0. And over here, this will be set to 0. So our approach works for the second test case as well. And the second test case is pretty tricky, contains negative numbers as well as 0. So it's pretty reassuring. So now that we have our approach down, let's code it out. So the first thing I'm going to do is to define the vector. So let me include vector. And let's define this vector as an integer, and this will be our answer. So we'll be using the copy constructor like this so that we create a copy of nums. And now the next thing that we're going to do is to populate this right to left product. So how we will do exactly that is by starting an integer I equals to num size. I guess actually just use the answer size as well. -2. So the reason is, as we discussed, like we will be calculating the product by going from the second last element and setting this product as the product of itself as well as the neighbor on the right. In this case, we don't have to do it for the rightmost because the number at the final position is already the right product of all numbers, including itself and to the right. So that's not necessary. So in this case, I will continue as long as let's call this index. This would be more readable. So we will continue as long as index is not out of bounds, and we will decrement index as we go. So at this point, we will take answer at index to be equals to the product of itself as well as the cumulative product on the right. So at this point, populate the answer with right to left product. So at this point we are ready. We can define a current index to be equals to 0, and we can define a left product to be equals to 1 over here. And our step now is to populate the product except self. And how we will do that is by, at each position, we will take the value as the product of left product multiplied by right product. And right product is the position to the right in answer. So let's say index plus 1. So now we can start off the index from index 0, and we'll be doing this all the way, let's see. Yeah, I guess we can do it all the way from 0 all the way until answer.size, index less than answer.size, index plus plus. Yeah, sounds good. So at this point, we will set the answer at index to be, okay, I guess one thing we have to do first is to update the left product. So if left product is, if index is more than or equals to 1, in other words, that is, if the current index is pointing to the second item onwards, then we will set the left product to be the product of itself and the number, and multiplied by the position at the previous index. And at this point, we will set the answer to be equal to left product multiplied by answer at index plus 1. So answer at index plus 1 represents the right product. So that gives us the answer. But the smart parrots among you would notice that I made a mistake here. And that's because if we have index equals to the final index, this will be out of bounds. So what this means is we have to do a check to ensure that we are not at the final index. So if the index is not equals to answer.size minus 1, in other words, this is not the final index, then we will do this. Else, we will set the answer to be equals to just the left product, and that will be sufficient. So that's pretty much it, unless I made a mistake. So let me quickly just do a sanity check. We first create the answer as a copy of nums, and we will use this to create the right to left product. We do that by iterating the array from the second last element, and we take the current product of array from the current position to the right as the product of itself, as well as the cumulative product on the right. So this makes sense. We then proceeded to iterate from left to right. Perhaps this current index is not necessary. Yeah, it's not necessary. I'm not using that. So left product is equals to 1. And in this case, we update the left product with the number on the left that we just visited in the previous iteration. And we set every item to be the product of the left product as well as the right product. So looks great. Okay, yeah, this looks fine. Let's run this. Hopefully I didn't make any mistakes here. Okay, thank goodness I didn't. And I did some sanity check there. So there we go. So in summary, our smart parrots will probably ask, okay, what's your time and space complexity in this case? So we take on time here to construct the right to left product, and we take another on time here to reprocess the answer product array as itself. So we end up with O2n over here, and removing the coefficients, this will be on, so achieves our objective. And for our space complexity, if we exclude the output array, this will be O1. We use a constant number of memory. I would still say this is kind of cheating, but since they allow us to use the output array, why not? Okay, so yeah, that's pretty much it for this question. I personally found the whole process of arriving at the optimal solution pretty challenging to me, frankly. This is not the first time I'm doing this question, but this is one of my first few attempts in C++. So yeah, that's it for this series. For this video. If you like it, thank you so much, and hope to see you in the next video.